Welcome to the 19th session of the flipped classroom for AP Calculus, section 2.9 in your book, Derivatives of Exponential and Logarithmic Functions. The derivative of e to the x, okay? I'm just going to give you the bare bones minimum that you need. In class, I will tell you how we come to this derivative, okay? But if y equals e to the x, then y prime is simply e to the x. So this is one of the few functions where the derivative of the function is the function. Now, what if y is e to the u, where u is some function of x? That means we're talking about a composite. What do you really need to do? You need to use the chain rule. So if y equals e to the u, then y prime is e to the u, derivative of the outside function, times u prime, derivative of the inside function. Okay, it's worth noting that you need to check the domain and range of the function you're taking the derivative of, because that will limit what the derivative is defined as, or what values the derivative is defined as. So when we look at e to the x, I can see that x can be any number, negative infinity to infinity, so the domain would be negative infinity to infinity, and that y, in other words, e to the x, I can only get values between 0 and infinity, not including the endpoints. Okay, so the range would be 0 to infinity, not including 0 or infinity. So the domain of the derivative is the same as the domain of the function, and the range of the derivative is also the same. I should mention that this range will not always be the same as the domain if we're talking about the derivative of e to the u, because whatever u is may help define what the range is. Sample problem. Let's find the derivative of y equals e to the square root of x. So we let u equals the square root of x. Therefore, u prime, or du dx, would be 1 over 2 root x. So y prime would be e to the u times du dx, or e to the square root of x times 1 over 2 root of x. Pretty simple. You try one. Find the derivative of y equals e to the negative 5x. If you get negative 5 e to the negative 5x, you are correct. Yay. Okay, before we go on, we need to review some logarithmic properties that we had in the beginning of the year and that you should have had in trig. So let's just talk about a basic log function, y equals log base a of x. We can write this, you might remember, as a to the y equals x. This is true because these two functions are really inverses of one another. This would also apply to our natural log, where the base a is e, which is a constant, value somewhere around 2.7. So we could say that if y equals the natural log of e, that would be the same thing as e to the y equals, if y equals natural log of x, that would be the same thing as saying e to the y equals x. Some other properties are the log of the product of two functions, or two numbers. The log of a times b is simply the log of a plus the log of b. The log of a divided by b, as long as b does not equal 0, is the log of a minus the log of b. And the log of a raised to some power n is n times the log of a. These are all properties that you can use to simplify your derivatives. Okay, the derivative of natural log of u. The derivative of the natural log of u, where u is a function of x, is just u prime over u. So now, if u were to equal just x, then that derivative would simply be 1 over x, because the derivative of x is 1, so it would be u prime over u, or 1 over x. The domain of the natural log of x is 0 to infinity, not inclusive, while the range is negative infinity to infinity. The derivative of the natural log of x can only exist at values of the domain. Therefore, 1 over x although it's defined at all values except 0, the derivative of natural log of x, the function is differentiable only at 0 to infinity, because those are the only values that natural log of x is defined at. Okay? Sample problem. Let's find the derivative of the natural log of x squared. This is a composite function, so we're going to use chain rule. Let u equal x squared, then u prime would be 2x. So y prime would simply be u prime over u, 2x over x squared, which simplifies to 2 over x. Alright, what I want you to do is look on page 231, 1 through 40. There's some problems there that deal with derivatives of the log base a of x, or the log of a constant, or a constant raised to a power. Those problems I've excluded, and I will talk about those problems in the next video, okay? But these problems that you can do will be enough to keep you busy. So the next video we will talk about how to find those problems and also do logarithmic differentiation. Alright? Have fun. Bye-bye.